chance to cover a very considerably large subject, a bit more breadth perhaps than depth in what I go through, but hopefully we'll just give a bit of a taster of some of the things that go on in geotechnical and drainage asset management in the railway environment. So just to give a bit of an agenda, I'll give a little bit of background, and then I will go through some of the challenges that earthworks and drainage present to people operating a railway, and some of the ways in which those challenges can be met and how the management is carried out. A bit of a look to the future, both in terms of changes to the way that the management's carried out, but also some of the challenges and how they're changing. And then hopefully we can leave some time for some good questions. So by way of background, railway earthworks are obviously are the reason why we were able to produce a railway that could carry the early trains at the low gradients that required. So crudely speaking, the railway earthworks are why we've got a railway there, and drainage is more or less the reason why it's staying there and keeping the earthworks in place. So the railway was constructed in a relatively simple way. If a valley was encountered, it needed to be filled with something, and typically that was coming from a nearby hillside that you had to get through either by constructing a cutting or by putting a tunnel through it and producing spoil in that way. So most railway operators will manage their earthwork assets in terms of cuttings and embankments, and they can be split down in separate ways, but typically they may be split down into cuttings that are formed in soil materials or formed in rock materials, and the embankments can then be made of the fill that's derived from those cuttings. And typically you'd end up with something like the figure top right, where you can move through the landscape, keeping low gradients low. Drainage is that there's many more asset types. These are just some images that are taken out of Network Rail's drainage manual, and the figure on the left just indicates that there's drainage associated with the track. There's drainage associated with moving natural water in the area through earthworks. There's drainage that's associated with slopes, and that's where an interplay between the assets comes in, which we'll be revisiting. And there are many different types of those assets, either considered as point assets, where you've got the catch pits, etc., or the linear assets that link between those and move water around, such as ditches, pipes that are buried or otherwise, and counterfort drains that you can see in the slopes. So a lot of the challenge that comes out of earthworks and drainage really comes out of the history of construction of the railway, which, this is a very informed audience, so I don't have to go into that too much. But in the area that I work in, we work for quite a number of clients that have got assets of different ages, and I think it's always useful to remember this bar chart on the left, which shows the ages of the earthworks and when they were constructed for, in this case, Network Rail's network, compared to a more modern network such as the motorway network in England that's operated by National Highways, or High Speed 1, the Channel Tunnel Rail Link, and then off to the right as well, we'll also have HS2 being constructed. So when the earthworks and the drainage were initially put in, the types of construction methodologies that were available were pretty crude, and some of these images on the right give an indication of that. The one on the bottom, I think, is a fantastic photo demonstrating the cut and fill that's required through one cutting, forming an embankment before you get into another cutting. But when you start seeing things like the rock cuttings up at the top there, constructed in the 1840s, things were pretty crude, and quite frankly, they were pretty dangerous as well. And formation of embankments was very much just throwing the material down, self-weight compaction of whatever plant or horses or people were going over it. In this case, it doesn't even look as if this end tip embankment is even going to have the vegetation removed. It's just material thrown down. So that kind of type of construction leaves a legacy, as does the construction techniques that were used to carry it out. Not much mechanization. Any help that was being used in the very early construction was coming from horse-drawn type wagons moving things around. So that legacy of the construction of the assets has meant that challenges have arisen, and as ever with any any developments that take place in asset types, there's been a series of key turning points. So this is particularly in the world of the earthworks. For much of their life, the management of those assets was quite locally carried out. Local, teams having lengths of the railway would be doing management of all types of assets. It wasn't really until the 1990s that more formalised management of earthworks came into place, particularly for Network Rail, but coincidentally also more or less at exactly the same time for a motorway owner like Highways Agency, as they were. But quite often it's key failures that are a turning point, and the A-Skill failure in January 1995 was a real turning point in earthworks and drainage. It caused a train derailment. It unfortunately caused a death, but not associated with the initial collision with the earthwork failure. Out of that was driven the real standardization of the way that earthworks are managed by Network Rail, and data started to be collected such that the first standards came out in the sort of mid 2000s, with two key standards that Network Rail still use to this day. One, the 086 standard for the management of earthworks, and the 065 standard that relates to the examination of earthworks. And that data collection started to become able to be carried out electronically at around about that time. And for a long time now, Network Rail have operated what they call the 065 earthwork database that JBA operate for Network Rail. Another major turning point that's more recent, and also tragic in that it caused 3 deaths, and this had particular resonance with both earthworks and drainage. So the Carmont failure that occurred in August 2020 was a very significant high-speed accident. I'm sure many of you will know all about that, but that drove quite a lot of changes. Obviously, there was the RAID report associated with the accident. I recommend that anybody that comes and works in our team reads that RAID report, because it is an extremely enlightening document about what it is that we're trying to achieve with the work that we do in earthworks and drainage asset management. How the opportunities that may have existed to avoid that happening have been very honestly looked at within that report, and are very clearly spelled out. And it's not just of importance to asset owners, it's also of importance to people that are out working in design consultancies and working as contractors building things. It's a very, very important document. And driven out of that, Network Rail commissioned 2 studies. One by Lord Robert Mayor looked at a review of the way that earthworks are managed, and that drove a body of work. And then there was also Dame Julia Slingo, who did a work on the weather advisory side of it, and the more watery side of it. And again, 2 really important reports that are really useful to read. So very quickly, and setting out a hell of a lot of work around it, the way that railway earthworks are managed is, as you might expect, through a consideration of risk. So with any asset management, first thing you have to do is define your earthwork assets. Network Rail and others do that by splitting them up into 5 change lengths, roughly 100 meters long, split them up into the asset types that I talked about at the start, cuttings and embankments. And then each of those are examined, mostly by visual foot-based examination, but though increasingly making use of technology. That is run through prioritization algorithms, which are calibrated to the failures that have been seen on the railway. And that produces an earthworks hazard category from A to E, which you can see in the chart on the top right. There is then a separate assessment that's carried out about the criticality of each section of the railway. So essentially, if there were to be a derailment at each section of the network, how bad could that be? And that's given a rating from 1 to 5. And then every earthwork asset can be placed on that risk matrix, and management actions are driven from that. So you can see from the table down the bottom, which is relatively recent data, in total, Network Rail have got 191,000 assets to be dealing with across England, Scotland and Wales. So a very considerable number of assets across a range of different geological materials, different heights and angles, a considerable challenge. Drainage asset management is quite difficult to sort of put into a single slide, but the chart on the left, I think, gives one idea of some of the challenge that comes with managing railway drainage. Is that it's not just about the structural intactness, essentially, of the drainage. It's also about the service that the drainage is providing. So you can have a perfectly sound drainage channel, culvert, but if it's silted up or blocked up and it's not allowing the water pass through it, then you've got a deterioration in the service that's providing. So these two interplaying measures of drainage need to be considered. What's particularly challenging with drainage is that the service of a drain can change from being perfectly serviceable to being essentially completely broken in no time whatsoever, essentially almost overnight. So the rates of deterioration of the assets and the amount of keeping up to date with the asset condition that you can do is a real challenge in drainage. The other thing is that drainage needs to be managed in consideration of what's the impact of poor drainage condition on the assets around it. So the chart on the bottom right gives an understanding of that interplay between the parent asset that you're dealing with and the individual drainage itself, and management in that way can be carried out. And I'll come back to that. The challenge really in earthworks is that they can fail, and they quite regularly do. And it's pretty easy to get a number of images of railway earthworks failing, because they do quite often have significant impact and can close the railway and hence make it onto national news. So the biggest challenge comes from failure of the earthworks causing the railway to be shut, slowed down, delayed. But there is also more subtle issues with earthworks, serviceability type issues, essentially mostly around embankments, can cause real problems with the track geometry. This is some really nice work that was done by the team at AECOM that looked at analysing repeat track geometry information, and we then did some work with them to relate that to the embankments and the geological materials that the embankments are made out of. And this gives you problems not just in the winter but also in the summer when you get clay materials embankments that shrink and swell. Drainage, one very obvious issue associated with I'll say water rather than specifically drainage is clearly flooding. So you can see relatively recent pictures of some flooding that you can see on Network Rail's websites. That's a very obvious sort of issue that you can see. But it's the consequential damage that's associated with drainage being in poor condition that is that makes things that bit more complicated with drainage. So the knock-on effects of poor drainage on the track and what that can mean in terms of wet beds, where you're getting vegetation growth in areas where it's consistently wet, or where drainage problems are causing issues to structures, whether that's the earthwork structures or whether it's in this case the wing wall of culvert. That consequential link, drainage links everywhere, and that was brought out in the little figure on the right here, which was originally in a drainage policy for Network Rail, but then it was also picked up in Syria's infrastructure drainage manual. Drainage sits at the heart of the behaviour of a whole load of other assets. So you get the direct flooding, you've also got water quality issues and pollution, you've got the impact on the earthworks and on structures and on track or pavement if you're in a road environment. On the right is slightly outside of the railway environment. This is a piece of work that we did on the motorways in England for Highways England. So it seems a no-brainer to many of us, the impact between drainage and earthworks, but we actually did some work to conclusively demonstrate that impact on the motorway network. And when we analysed over 700 failures that Highways England had seen, we were able to demonstrate that 74% of those could be directly related to drainage one way or another, either in terms of poor drainage in poor condition, or they're just not being drainage when there should be drainage. So whilst it seems blindingly obvious, actually having some published information that relates that has been very useful in making the case for drainage being a very important thing that needs looking after. Drainage and water and the impact of weather on earthwork failures, again, it is blindingly obvious, but it is also borne out in the data. So this is from Network Rail's CP7 earthwork policy, and the top is just showing a long-term chart of monthly rainfall as a percentage of the long-term average, and on the bottom the red peaks are the monthly earthwork failures that are seen, and then the averages as cumulative moving averages are shown in the green and the blue lines. And very clear relationships between the peaks of rainfall and earthwork failures can be seen, as can the overall creeping increase in the monthly number of earthwork failures that are being seen. So there's clearly a deterioration of performance going on, which you can see related to the weather. I really like this chart that again is from the earthwork policy, where the earthwork failures have been split out into which of the seasons they occurred in. So the color coding of the dots splits them out into autumn, winter, spring, and summer. And the left-hand one is just raw earthwork failure numbers. And then on the right, it's where the failures have then been expressed as a percentage of the long-term average numbers of failures. And you can see that what's becoming increasingly a challenge is the plot, the dots in the top right of the right-hand chart, where we've got summer failures occurring, where we're getting large volumes of rainfall occurring in a very short amount of time in the summer months. And that's driving different failure mechanisms, which I'll come back to, that aren't the usual, it gets wet in the winter, we get more failures in the winter. So almost a new challenge is arising. So a bit about earthworks management. Again, I'm going to focus mostly on earthworks here. I've already touched on this. The majority of the data collected at the moment is examination-based. It's foot-based visual examinations, making use increasingly of desk-based tools, and asset owners such as Network Rail are getting more and more useful information available to them that you can view in the desktop. There's the concept of evaluation, where all of the information is gathered together and management actions are derived. A level above that is assessment, which is then starting to get into a calculation of stability and capacity, and I will come back to that because there's new guidance that's now come out for that. And then ultimately something can be done. So it may well be that an intervention is required to deal with an earthwork issue, or mitigation measures need to be put in place to deal with particularly adverse weather. There's huge depth behind the work that's done here, but this is really just demonstrating how the earthwork hazard categories were derived by looking at real failures seen around the network, the observed information gathered from examinations, and trying to create an algorithm that as best as possible looks for the precursor indicators of failure seen in examinations and then ranks the earthworks associated with those. What you do see from this, though, is very clearly spelt out that management of earthworks is an inexact science. So the red line on the left-hand chart shows that you still get a significant number of failures from the earthworks which are in hazard categories of C and below. In fact, the greatest number of failures come out of the asset category of C. So it is a challenging area. And I touched on this before. So fundamentally, Network Rail has a series of hazard indices for each of their asset types, which derives the earthwork hazard category. And then the criticality is derived by looking at information about particular areas around the network, looking at line speed, the number of trains per hour, curvature, and the proximity of line size obstacles if there were to be a train derailment. And every asset can be placed on that and management actions associated with it. More recently, since kind of I think about 2015, a body of work has been done to start going beyond that assessment of just surface visible techniques. And a major advance made by Network Rail was in looking at the fundamental stability of soil slopes through what's called the Global Stability and Resilience Appraisal methodology. So this essentially split the assets up into geological materials, determined suitable parameters for them, and ran a whole series of slope stability analyses that you can see on the bottom left to derive stability charts like the one bottom right, which effectively allow you to put every asset onto an angle and height chart and determine whether soil mechanics will tell you whether an asset should be standing up, shouldn't be standing up, or is sitting in an area in the middle where you really need to understand a lot more about the particular characteristics of that slope. So this fundamental slope stability assessment methodology has been applied by Network Rail. And this chart from the Network Rail Earthworks technical strategy demonstrates the challenge that a legacy asset owner has with earthworks. So this is for high plasticity clays. The red dots are where failures have occurred, and you can see a really strong clustering in the area of steep and high slopes, and fewer as you move to the lower angles and lower heights. The obvious challenge comes here is that the grey and black dots are the other assets. So these are assets that haven't necessarily failed, but there is a huge number of assets that are sitting at an angle and a height where soil mechanics is essentially saying that they shouldn't be standing up. So this gives a real understanding of the legacy that's faced. So GSRA is one body of work that's being carried out in the last sort of 10 years or so that's now enshrined into a literally brand new module that Network Rail have put out. So as part of their 086 Management of Earthworks standard, there is a new module 2 on earthwork assessments. There is also a new one on earthworks evaluations, but I won't cover that. This absolutely sets out to give more structure and detail around the statement on the right, is that assessment is the qualitative or quantitative determination of the stability of the safe load carrying capacity of an earthwork. So it's fundamentally looking at, have we got earthworks that have got the ability to hold themselves up above the railway or hold the railway up on an embankment? This has gone from something like about 20 pages to over 500 with the amount of work that's been brought into it. And the figure on the right really gives a good understanding of what's going on with the new guidance. Essentially, you can work at it. The end point is the top. So the outcome of an assessment is fundamentally determining for an earthwork asset. Is it satisfactory in terms of its load carrying capability or stability, or is it unsatisfactory, or has the work that you've done turned out to be inconclusive? And you can determine that from a whole series of essentially assessment techniques which give you different outputs of different types. You can get factors of safety, you can get serviceability limit state deformations, you can get kinematic admissibility assessments of rock slope discontinuities, and you can carry out different levels of assessment to determine those outputs, which you can drive through to the outcomes. So from level 0, the idea is that will use automated methodologies such as the GSRA methodology to give you those outcomes where your level of uncertainty is reduced somewhat, but you've still got quite a few assumptions that are made, all the way through to level 3 assessments, which is where you really would throw the kitchen sink at it. You would be doing ground investigations, you would be carrying out the best analysis that you can, monitoring groundwater over a longer body of time. And that's fundamentally driven by a series of elements of knowledge that you need to gain. And these are sort of shown on the right. One of them is grouping together the geological materials around the network. So that the standard includes within its 500 pages about 200 pages of mappings between all of the British Geological Survey geology codes and the 11 geological cohorts that everything's been grouped into. There's then a new classification or clearer classification about different failure mechanisms, building on things that already exist in the literature, but also picking up the way that Network Rail has done things and classifying 19 failure modes, both in terms of how they occur, how the analyses relate to them, but also how they are recognizable in the field to try and drive some standardization of the way that the assessments are carried out. And there's the concept of generic ground models at the lower levels of assessment. So there are set out a series of indicative ground models for both embankments and cuttings, so that when assessments are carried out, everybody uses the same nomenclature. So everybody will refer to a cutting as being ground model C2W, for example, if we've got that case in the asset that they're looking at. At the bottom of the chart on the left is where the data is coming from, essentially. So increasingly, more and more is able to be done by making use of desk study sources, geospatial procedures driven from increasingly sophisticated things like LiDAR-derived digital terrain models, etc. But you also come back to the more, things that have been for quite a number of time: desk studies, site inspections, ground investigations, and there's a specific section on the importance of geomorphological mapping for earthworks. It can bring you a huge amount about the understanding of assets, and also where monitoring of earthworks sits within that framework. So again, I'd heartily recommend to everybody on the call, get that downloaded from the standards website and have a look through that. There's going to be a lot more publication and more documentation and presentations done on that in the coming year. So looking to the future, so railway earthworks are already deteriorating and showing their age, but work has been done for a series of asset owners to actually demonstrate that we can see deterioration of assets by looking at the repeat inspections carried out over the 20+ years that asset owners have been able to collect that data. And the chart on the right is derived from Network Rail's work, and it very clearly shows a degradation in the condition of earthwork slopes, and you can clearly relate it to geological characteristics. So in this case, the plasticity of the clays of embankments, the higher plasticity clay assets are degrading faster than the lower plasticity clay. So bearing out what we would sort of tend to think. The left-hand side is a conceptual diagram that comes from a systems engineering paper, which is really good, which gives this concept of deterioration being a bathtub. In this case, the bathtub's upside down because it's performance, not condition, on the left-hand side. But perhaps what we're seeing is that new asset owners might be in the bedding in period of their assets. Someone like the motorway network might be in a reliable period, and railway owners such as Network Rail are perhaps seeing their assets in that sort of degrading and unreliable space, and that's the challenge that they see, and this is demonstrable in the data. Another really interesting piece of work that's been carried out recently that I was part of was the Achilles program, which looked at bringing together research from across a range of considerable number of universities, and tens of researchers have contributed to this wider program. This actually carried out incredibly detailed slope stability modeling, feeding it with real daily weather information, and that weather could then be manipulated from taking a climate trace for the current climate and just winding it forward, but then also taking some of the climate projections from the UK CP18 modeling, feeding that, converting that into daily weather, and then modeling that through the assets again. And you can see in this sort of colourful charts on the right, the top is a factor of safety for model slopes through time from 2020 out to sort of 100 years hence. And a factor of safety of 1 theoretically is the point at which earthwork slopes are failing. And the reddy orange colours are factor of safety in the summer, and the bluey colours are factor of safety in the winter, showing that change through the seasons. So with the top one, which is just taking the current climate and winding it forward, earthwork slopes are kind of good for another 100 years. Start feeding it some of the extreme climate models from UK CP18, and you start seeing that the assets are failing in half the time that they would do if the climate carried on as it was. So quite clearly seeing that climate change is going to have an impact, and is already having an impact on the assets. And climate change, it manifests itself in ways like that, such as the failures. But we talked earlier about serviceability state. You can also quite clearly see the impact of climate change on increasing extremes between the winter and the summer, and the shrink swell behavior that means for certain geological materials, particularly, again, the high plasticity clays. And very clear measures can be seen relating track movements to soil moisture deficit associated with the drying out and re-wetting of clay embankments. But it's not just as simple as wet and dry. Another climate risk, which is it's not confined to sort of California and places like that, is wildfire risk. So this rather terrifying image on the right here is from the side of the motorway network in Kent a few years back, just demonstrating how, you know, a wildfire can and has taken place in the UK, and as we get drier summers, I'm saying that as I look out the window here in Sheffield at a pouring day, but we are forecast to see a lot drier summers, and this wildfire impact can have a real can be a real problem for earthworks in changing the vegetation, and obviously the hazard that the fire itself is causing. Another interesting piece of work that Achilles got involved with was looking at what the climate change predictions might look like for design of new earthworks. And I won't name the railway that's shown on the left, but I think you can work it out. So this in the sections towards the top of that, where construction was planned in Mercia mudstone slopes, the modelling, again done by the Achilles project on the right, shows that slopes cut at 1 in 2.5, 1 in 3, and 1 in 3.5 with a current climate would show a nice factor of safety for 120 years, which is typically the design life that asset owners ask for. If we then put in a possible future climate similar to the ones shown earlier for high plasticity clay slopes, this is more in the sort of medium plasticity, failure is starting to be seen at 80 years. So there's a challenge here for the designers of new assets, is that just considering that you will model things based on how things were in the past and how we've got away with things to date is difficult to demonstrate in a changing climate. And we're going to need to be thinking a lot more about what it is that's keeping those slopes up, and how we look to make sure that we design earthworks for future adaptation, and particularly properly undertaking maintenance. Another driver looking to the future more in the way that things are carried out is removing that reliance on foot-based inspection, both from a sort of quality of the data, but also from a purely safety perspective. The less time that we can have people walking over earthwork slopes, the safer it will obviously be. And there's a really good, I would commend the earthworks technical strategy that Network Rail put together from a few years ago now, but still very, very useful. That sets out some of the new technologies that are coming into use. And I particularly like the image down the bottom demonstrating an earthwork slope vegetated, and then where the DTM has been calculated from LiDAR and the vegetation removed, how clearly you can see counterfort slope drains in those slopes. We absolutely need to be making use of this type of information. And there's other areas. There's monitoring of slopes, and there's accepting that we may not be able to capture and remediate and intervene on every single earthwork asset, but we can get better at the monitoring that we carry out, looking to determine where failures have occurred or are about to occur, so that trains can be stopped before they come in and come into the area where a failure has occurred. And that might be sensors on rockfall nets. It might be tilt meters, which are increasingly being deployed around the railway network, and you'll probably see them if you have a look out the window at a number of earthworks now. Or making more use of remote sensing that can be rapidly analyzed, because one of the things about remote sensing data is that you generate a lot of data, and it's not really much use if you can't convert that into information that you can act on very, very rapidly. And that's where quite a number of changes are being, a lot of work is being put out. So just really to come towards the finish, we're now into control period 7, and there's a really clear focus on earthworks and drainage coming into control period 7. There's serious commitment that's been put into both of those asset types, and a number of things made their way into mainstream press, not just the engineering press, on the amount of effort that Network Rail is and will continue to be putting into the management of drainage and earthworks, which is it's very encouraging, and it's recognition that the people are really starting to understand the importance of both of the asset types, in keeping the railway operating in the way that it needs to operate. So there'll be plenty more developments coming in the future years. So I thought I'd just finish off. I've blasted through in 40 minutes there, quite a considerable amount of information, but not into much depth. I would absolutely commend to you a number of talks that you can get from the excellent PWI Knowledge Hub. And I listed out a few by just having a look through yesterday, but there are a number of really, really good talks by people who are out there carrying out this work at the sharp end, both on geotechnical assets and earthworks, and on the drainage assets, which I haven't touched in huge depths, but really, really good talks that if you want to get more information on this really interesting and challenging area, I'd highly commend that you have a good look through each of those. So thank you very much for listening, and we've got a bit of time, I think, to see what questions came up.
That's great, Chris. Thank you very much indeed. It was an excellent presentation. As people are reacting to that, it's very informative indeed. If I could just ask one question myself before I come to those in the chat, being a bit selfish. So as the assessment tool moved from the grid, if you like, the red, amber, green, into this new thing, Earthworks Assessment Guidance, which looks very comprehensive and complex and complicated, I was just wondering, like, from your perspective, what do you see in terms of helping people to be trained to be able to use that properly?
Yeah, that is a really good question, Joan, because guidance is absolutely no good if it sits on the paper and the people that need to enact it can't use it. So so there's going to be a real effort on that in the coming year, to translate between what's written in the standards and kind of getting that out. There are sort of internally, Network Rail have got training courses that they want to they put together for their own staff, because quite a lot of what's in the standard is inherently linked to tools that Network Rail have available to them in the office. So it links in with training that exists for that already. When it comes to the training of the sort of the wider supply chain, if you like, there's going to be some publications. We're putting something together for Ground Engineering magazine in the first instance, just to make people aware of it and what's out there. We're going to be looking to get out to do things at conferences, and then potentially we may look to produce kind of training videos and the like to give a better understanding of it. But it's really giving as much help as we can, and anybody that's got questions, asking them, and we can do what we can with them. That's a very good point.
Right.
It's not as complicated as it looks. It's actually the standard gives quite a lot of detail about how to use it.
Okay, I guess if it's in your discipline, yes, but it's such a big change, isn't it, from looking at a red, amber, green sort of assessment chart to what you're currently working with it.
Yeah, fair point. Yeah.
Okay, so coming to the questions in the chat then. So there's quite a lot of comments in here, and I'm not just going to address the comments, but someone has specifically asked if you can have the highways document that you mentioned. Chris, I don't know if you're able to put a link into the chat, or just tell people they can get the highways report.
74% one. Yeah, so it's so it was published in the Quarterly Journal of Engineering Geology. I can give a link to where it is.
Yeah, that would be perfect.
But I think to then get it, you need to have membership of the Geological Society or a link through it. I think it's not freely published. I don't think.
Okay.
But I'm very, very happy to put a link into to where that's published in QJGH. Actually, and there was a presentation that was done on it at a conference a few years back, and that is available for free. So I can give a link to that as well. No problem.
Brilliant, thank you. And then people can come back into this afterwards and they can see those, pick up the links. That's great.
Yeah.
Right, now then, let's see. I'm going to go, had a very comprehensive comments from Mark Craig, and then he had a question specifically. And I mean, Mark, I don't know if you're there, if you want to ask your question.
Yeah, can do. Thanks for the presentation, Chris. So I currently reside in Scotland, so I'm familiar with some of the things that you mentioned, both on Carmont and some of the other ones. So my question was pretty much, I'll just read out the question. So I've extensively managed two earthwork frameworks over CP5 and CP6, probably about 22 years experience with earthworks in Scotland before moved over to electrification. But it was just regarding the summer failures. For me, this obviously isn't a new trend. At Network Rail, for instance, in July 2012, there was a derailment at Lochtreeg in the West Highland line where there was 5 wagons had derailed carrying aluminium powder for the smelter. That was due to rotational failure landslip. There was previous works done, which was gabions at the toe of the slope, but hadn't picked up any of the previous stuff up on the crest of the slope. And again, probably in 2010, there was a derailment in the Fogs of Crooken line where boulders, where it was due to poor drainage and poor water management, has led to erosion for fielders coming down. So for me, again, these were both outside Network Rail boundary. And the question from my perspective was, third party risk is obviously Network Rail's biggest issue. But they're obviously not funded beyond obviously their boundary. I know previously before I left, they were looking at potentially commissioning studies aligning with Transport Scotland and stuff. But for me, that's where probably their biggest risks lie, is either drainage or poor landowner management for adjacent boundaries. Obviously, they have examinations, but they don't obviously stem as far as that. And I was just curious, do you know of anything that's either happening at the minute in a separate work stream, or have you got any previous experience with that? Was the first part of the question.
Mm-hmm. Yeah, no, really good points, Craig. And it's not just Network Rail that has those issues. I mean, Transport Scotland have them with things like the Rest and Be Thankful road, where there's the huge thing. So I think a key thing is this is understanding of the water catchments associated with those types of failures is an area where both Network Rail and National Highways are putting in effort at the moment. And I know listening in Ireland at the moment is on the call is Mona, the professional head of drainage at Network Rail, who was giving a talk yesterday about the catchment modelling work that's been done. So I think one key thing that particularly in that space around kind of flow type failures is that the earthworks community and the water management community, I'll call it that, not drainage, needs to be kind of coming together and working on those challenges better, because as you say, the water is coming from outside the boundary, and heavy rainfall it doesn't care where the ownership boundary line is. The water's going to collect and it's going to go where it needs to go. And you can see quite decent relationships between catchment models and the earth failures that you see. The challenge becomes is that you can also see really good relationships between large catchments that give you high risk where a failure hasn't occurred. And you end up with that the classic balance of the known knowns and known unknowns, and you can't remediate everything. And the third dimension that comes into that side of things is what the weather is doing and the weather forecasting. And that's why coming out of Carmont, as you would have seen, the part of the assessment was around what's gone on with the management of the earthworks and the drainage, but part of it was about weather forecasting. And I know that Network Rail are working with Met Office within this, and it's that relationship between earthworks, drainage, and what's going on with weather is where the answer lies. If you look in the new assessment guidance for Network Rail's earthworks, the flow type failure one is currently got the sort of watch this space for further developments part, because it is probably the most challenging earthwork failure type that exists, and it certainly seems to be happening more and more.
Yeah, that would probably be true to Scotland as well. Part of the Fort William, they've got a branch that branches off 36 miles for Fort William run to Mallaig, and the topography is massively sidelong. And I think there's been previous failures up there, the Lockheed failure where they've put in catch fences and monitoring and stuff. So no, that's interesting. And so the second part, it was just more or probably less of an issue, but it was just were you aware? I know we had many problems when we were doing our Form A's or our Form 1s, we would always do for network rail, so you could try and quantify the benefit of implementing the proposed works or interventions when you would rescore how an examiner would look at an earthwork. And I know there was always a few gremlins in the double SHI should I say, rather roundabout. If you block ditches or crest ditches, or if you added rabbit infestation, it actually decreased the score. It actually increased the score rather than decreasing it, so it would make it the earthwork more improvement rather than less. So I was just curious, if things like that have been addressed, because I know that was causing issues.
It kind of is. It was one of those perverse unintended outcomes of the statistical analysis. It was never really suggested that you should install rabbits as a means of but it absolutely did kind of give a weighting that would reduce the score, and it essentially was driven out of the pure statistics. So for those algorithms, they are calibrated against the failures that were seen at that point in time. You could if you redid it, you'd get a different answer. To redo it with, at the point that was put together, techniques were being used that were sort of, the state of the art for the time with the available data. Right now, Network Rail are looking again at revisiting the prioritization algorithms to try and be more cognizant of the changing characteristics that come into it, and more self-updating and less prone to the quirks that simple algorithm kind of created. But in answer to your question, that algorithm is still in place. That's still driving the EHC values. But what Network Rail are looking to with the assessments is, over on top of that, you've got another lens to look through with things like GSRA or things like that. It's kind of recognizing that it's a difficult area. It's going to keep me in my career until I retire.
Wow. Well, there's a lot to go on, isn't there? I'm going to move now to a very interesting question which has come up from Rob Buckby. Rob, I don't know if you're there and you want to ask your question, or I'll do it for you.
Yeah.
Go on ahead.
I'm here.
Go on ahead. I think it's a very interesting one.
Yeah, absolutely. Just keen to understand what effort has been put into linking all the data gathered for earthworks into the signalling system to potentially prevent failures.
As in failure triggering the signalling to stop a train, to prevent it hitting, that kind of question.
Yeah, exactly.
I'm fairly sure, but there might be someone from Network Rail on the call who could answer better. I'm fairly sure that in some areas where did you see the picture of the tilt meters? So there are a number of places where tilt meters have effectively been installed. So they've been put into an area that's prone to failure. And they've got just like a tilt meter sensor on them, and if they move, that initially fires a camera off to take a photo just to check that something is actually happening and it isn't somebody that's gone by and kicked it. I'm fairly sure that in some areas in the southeast, that is then tied into the control so that it actually will stop the signals. How interlocked that is, how automated that is, I don't know, but there might be someone on the call that knows it. But links have been made to try and do that. Going way back, there was a signalling interlink in Scotland, which I think was called something like Anderton's piano wires. It basically had a series of wires on the bottom of a slope, and if a boulder came down and tripped it, it would trip the old style semaphore. So it's kind of there is a long history to it, but there are interlinks. I'm fairly sure.
Someone has put a comment in the chat to that effect. So it says they can install simple fiber cable that listens for rock falls, derailments, cable thefts, and even wheel cards of elephants. If you find any of those around in your infrastructure.
Yeah, it has that. I mean, and again, that has been tried with sort of mixed results. I think the challenge that you get with it is false alarms, as with any type of monitoring. And I think quite often the struggle has been with some of those has been proximity of passing traffic on roads and things like that. But again, these technologies are being often tried.
Okay. So I hope that answers your question, Robert. There's a lot of comments here in the chat, Chris, about this whole thing about third-party people and their water, which doesn't belong to Network Rail, but ends up in Network Rail.
Quite.
And Martin Wilson's put a good comment in. It says, Network Rail has a standard on geohazards, which considered the risk from outside party slopes. All slopes outside the Network Rail boundary have been given a risk ranking. It's called CHOPS, CHOPS, A to E. And Network Rail are starting to assess these and will be continuing over the next two or three control periods.
Yeah, that's absolutely right. Martin's absolutely right. So that considered a series of hazards, rockfall hazards, and those types of things. Largely, a lot of work done by the British Geological Survey to bring that in. So that's part of the picture as well. What Network Rail has is a series of different tools looking at different problems in different, through different lenses. I think is the nice way to describe it.
And that's certainly one of the things that's come across to me in this presentation is, it is very complicated, and there are a lot of tools that can help you, but you need to know which one to use in the correct scenario, I guess.
Yeah.
And just to finish off, because we're getting a bit close to the end, Daniel Pike has asked an interesting question. Daniel, are you there? Do you want to bring up your point yourself?
Hi, yes. Sorry, I was just asking, there's obviously lots of effort gone into the modelling of the risks, but how much effort by comparison is going into detecting these as they happen to stop trains running into them, which is kind of linked to one of the other questions about interlinking signalling, but perhaps a step back.
No, that's a really good question. Increasingly, quite a lot of effort. Particularly in certain of Network Rail's regions. So the southeast of England is deploying. I wouldn't know the numbers absolutely, but there's been quite a few in the geotechnical press. There's been quite a few interesting articles put out where particularly use of tilt meters on slopes is being deployed, and they have captured failures that have occurred and prevented accidents. So more and more effort is being put into it. Another area that's really interesting that Network Rail have got at the moment is they're making use of satellite INSAR data, which is satellite interferometry. So looking at changes detected through repeated passes of satellites, and they're running a kind of a long-running pilot of bringing that into some of their viewers to look for slope movements detected remotely.
And that was the previous presentation we had 2 weeks ago. Chris focused on that.
Good. Of course, yeah.
So that was very interesting. Okay, so we're coming close to the end now of the time, and I know that people will just drop off at 1:30, so I don't want to finish up without having time to say thanks very much to Chris. I'm sure we would all agree that's been a very informative presentation, generated a lot of comments in the chat. Certainly a very big challenge, Chris, for Network Rail, and for people to learn how to use all of these tools that are available to help them in these assessments. And just to remind everyone, this is the last Lunch and Learn now until September. So please come back and see us in September again. We'll be back up and running on the 2nd of September. But if you look out on LinkedIn, you'll see the forward programme being advertised. Okay. Thank you very much, Chris. Thank you.
No problem. Pleasure. Really good questions. Thank you.
Thanks, everyone. Bye.
Cheers. Bye.